progress your way through the different types of enemies that appear and figure out how we're going to save them. All right, to download the project, all you have to do is use the link below in the description. It's going to bring you to this page. This is just the main save and load project. The main branch is fine, should be the starting point of the project. To get started, all you have to do is click on this code button and click download the zip if you just want the file. You can also clone if you want. It's up to you. Once you've opened up the project, you'll see something like this. Open up this block dodge folder, go to screens, open the save and load example TSCN. We're going to press F6. WASD or WASD keys are used for moving your block around. Your goal is to dodge all the flying blocks coming to hit you. The progress increases. These red blocks come out of nowhere and you're trying to not die. But if you do die, you're given this game over screen and the load last save button does not work. Let's go ahead and get started saving. Let's go ahead and open the save and load example.gd, the script file. There's a lot of code in here. You don't have to worry about pretty much any of it. In fact, we're going to scroll all the way to the bottom, and then we're going to go in here and new line this and create a new function. And we'll call it save. Then we're just going to set up pass. Here we got our save function stubbed out. Let's go ahead and stub out our load function, which you cannot use load because it's a reserved word. Function load save colon, and we'll just pass there. First thing we want to do is figure out how we're going to save and where. We're going to use file directories and put it into just a save file. Put this in a directory of its own and not mixed with other files. To get started, let's create a new variable. Call it dir directory equals directory dot new. We need to check that the save file exists because it could be the first time they're running the game. If not, the directory exists for a user / save. And if this is the case, directory, go ahead and make us a directory and let's use that same path. Now, a quick note on these, this user path here, that is different based on Windows, Linux, and Mac. I will post a little image screenshot of the different directories here. Just note, you can also customize this in the settings. Go ahead and get rid of that pass now, where we're going to say, hey, I want to save my game. It is a file, new. And let's go ahead and try to open it. Save game.open. We're going to use that same file folder structure. This time we're going to say game data.save file.write. And then we're just going to define a variable where we're going to store the save data. In this case, it'll be a var save data equals just an empty dictionary. We're going to come back to actually saving players and enemies. Right now, we're just trying to make sure that the framework is in place so that you can scale it to all of your entities in the future. Let's go ahead and leave a comment to do. Then take the save data, convert that to a string so that we can then save that down to a file. Var data string equals var to string. This is a handy utility method that takes any variable and turns it into a string. We're going to reference our save data object. We're going to say, hey, that save game file, let's go ahead and store the string, data string. Say save game dot close. Now let's go ahead and stub out the load save method. We can get rid of this pass. We're going to create a variable, which is the save game file.new. If not save game file exists, user / directory, and the same file, game data.save, colon at the end, print, there was no save file detected. Now that we have a file, save game dot open, user again, save game data dot save file dot read. We're going to do the same actions we did to save it, but in reverse. Data string. Let's go ahead and get the save game's text. Get as text. Save data is a dictionary. There is a string to variable method that allows us to take that data string and turn it into a dictionary. We can even print save data, and we can now save game.close because we do not want a memory leak. We can test this, and let's go ahead and save test. We should see that showing here. These methods are not being called yet, so let's go ahead and in the on ready. Put it in the front here. Load save. To add the save, we just need to put it in a place that makes sense. We're going to put it on this on progress timer timeout. After the progress has increased for the player, go ahead and just save. It'll save for every percentage tick, which isn't a bad idea, but it's not perfect either. Now we're going to run this. Well, that's interesting. It doesn't tell me it's wrong, but this is file.read with caps lock, but it didn't give me an error. How interesting. Let's try this again. No save file detected. We get killed by the red bar of death. And look, there it is, a save test. Next, we're going to talk about saving the player. Now, I know I said we would go right into saving the player, but there is one tiny optimization we're going to need to do, and that is to really notice when you end up repeating yourself. We're using the user save and the user save often here, and there's a chance you could mess up one of the spellings like user instead of user, and then your whole save system will not work. To protect you against that, best to put these in a constant, so then you can change it one place and you don't have to change it in 3 to 5 places later. Go ahead and copy this user save, bring it all the way up to the top here, create a new variable, and let's call it the save directory. And then copy this down, come down here. We're going to replace save directory and a save here. This game data save, let's copy that, come up to the top like we did here, and let's go ahead and make it a save file. Game data.save. Come back down here. String. And then we're gonna say save directory, comma, save file. Now it's cleaner. You know this is the save directory. It's opening the save directory with a save file. And now you can just copy this and paste it everywhere you like. And now it's in one place and it's reusable. If we go ahead and run this, you'll see that everything still works. Game didn't crash. You still die like normal. And the save test is still being loaded properly. Let's get on to saving the player. To add saving to your player, we need to open the actors folder, player.tscn file. And all we're going to do is come over here to the node tab by the inspector. We have to select the player root node, and then you see these signals and groups. We're going to click on groups, and in this little box here, we're going to add the word savable. Now that that's done, click on add, save the file. Now go to the script and make sure you open the player.gd, or you can double click on the player.gd file here. And similar to what we did in the save and load example file, we're going to create a new function in here and we are going to call it save. We're going to return progress.value. Get the position on the X, position.x, position Y, position.Y, and then just to make the indentation clean, you can kind of just set them up like this. Now let's come down here and let's copy that same load function from the save and load example and call it load save. This time, we're going to do something a little different, because we're expecting to get data from that save and load file. What we care about is then just some data that's going to be passed over to the player. That data could be null. It could be bad data. First thing you should do is just check if not data, then just return. We're not even going to try to load anything if the data is invalid. To get the data back out, we're actually expecting it to be in this same exact format. Progress.value equals data progress. And this is the key that we created here. And we can do the same here. We can say position.x equals data position x, position. Position.y equals data position y. This wraps up the player side of implementing a save. Go back to our save and load example. Let's go back to the save method here. Now we want to get the save from our player. We see the player here and we notice But the group is there, so we can get rid of this test because we don't need it now. We need a way to get all of the objects that are subscribed to the savable group. Find savable nodes. And we're going to get the tree. We're going to get the nodes in group. And we're going to make it savable. For savable, ind find savable nodes. Now we've got all of the nodes that are going to be saved. If not savable dot has method save. Savable node is missing a save function. Skipped. Continue. We then get to use this save data object. Save data savable dot name player in this case equals savable dot call save. This is going to call the save method, return that dictionary we created, put it into the save data. We can actually test this. Before we even worry about loading it to the player again, we can run this. Instead of save test, we're going to see player, their position, and the progress. Come through here, get hit, die, hit start over. Player, their position, and the progress being 5. We now need to say if the save data has player, which I've already done here, then we can say player dot load save and then just pass it save data with player. If we run this, F6, notice that it saved us at 5%. Loading last save doesn't do anything yet, but if you start over, notice that our progress is there. Our position was saved. That moves us to our next section, which is hooking up this load last save and truly making the start over button start over the scene. Now that we have saving our player done, we have ran into the issue where every time we click start over, it's loading the save. We now need to distinguish the difference between a start over and loading the last save. To do that, we just need to come over to the game over screen, which is this gameover.tscn file. And you can see it here, has load last save, start over, and quit. The associated code is in the gameover.gd. And you'll notice it says on checkpoint pressed. That's only because when I was first building this, I figured I was going to build a checkpoint system. I'm just trying to make it really simple. On checkpoint pressed is the same as clicking on load last save. The on start over pressed here reloads the scene, and on that on ready function, it loads the save file, which then acts just like load last save. So all we need to do to make load last save work is actually do the same thing that start over is doing. So we can copy this method and replace pass with that method. And now, load last save is working. The last thing we need to do is make this start over, delete the save files that we have. We should just create a new method, and we'll call that clear save data. As simple as that. Function doesn't exist, because we need to come on down here, create a new function called clear save data. And then what we're going to do to clear the save data is just find the directory where our saves are held and just delete all the files that are there. This way, if you have multiple files, you can just delete them all here and you don't have to worry about it blowing away any other important files you might need, which is why I always create a save directory. So let's go ahead and say variable dir for directory. Make a new one of those. Next, we need to make sure that the directory exists because you don't want to run into an issue where they load the game for the first time and there's nothing to delete and it fails. So to get around that, we just say if directory can open our save directory, and this OK check here lets us know that, yeah, I can open it. The directory system can say, yep, it's fine, I got this. Now that we've opened the directory, let's go ahead and get all of the contents of that directory. To do that, we say directory.list the directory. Begin, which really just starts streaming in all the data that's within the directory. And we only care about the files within this current directory. So we can actually skip some navigational items by saying true. Feel free to look up online what that does exactly, and it makes more sense. Next, we want to get the actual file name within the directory. So we say, hey, equals directory.get the next one. In our case, that will be the only file in this folder. But if you had multiple files, this would go through all of them. While the file name does not equal empty string, let's go ahead and then just say, hey, directory, let's go ahead and remove this file. And we can use what we did earlier and do string user /save/ comma file name. So now that'll delete every file in this directory. And then the last thing we need to do is take this file name and get the next object in the stream. And there we go. You have successfully cleared all of the data. So we can test that out real quick. Go into F6, do it from the game over screen. Let's say we start over here, we're at 0. That's great, we're in the center. If I come down to the corner and load last save, I should be in this corner. And there I am. Granted, the enemy's not saved yet, but that's what we're on to next. Before we dive right into saving them, let me explain these enemies. The red blocks that come down and try to hit you, and you have to move out of the way. After you hit roughly 20%, the blue style of these enemies show up, but this time they appear on the left and they come towards the right, and you have to dodge those and the red ones coming from the top. And then roughly around 45-50%, we have these red square enemies that rotate and are just flung right in your direction trying to hit you. These are all spawned in and dynamic. Open up the actors folder, click on the enemy long.tscn file. If you look at the 2D view, this is that red enemy we saw. Click on the enemy long. Click on the node, add savable. There's not like a blue enemy long. That's because the blue ones are actually this same enemy. They're just rotated 90 degrees and they're colored blue. By saving it here, we account for both types. Then this enemy rect, we do the same thing. Make sure you're in the node, click on the groups, put in savable. Let's go ahead and open up this enemy's script file, add the save and load data methods like we did for the player. Function save, return a dictionary. And if you ever want to know what you should be saving, you can just look at the variables that are defined and either just save those or look to see in the code what gets transformed. I'm just gonna fill this out real quick and you're gonna see it when it's completed. Power of editing, you didn't have to watch me type all that. Just did these primary variables. Do the same for load save. And we're going to pass in that data object. We're going to always say if there is not any data, just return. Let's be safe. Just like we did for the player, we're going to just load the data like before. I'm going to go set this up real quick and I'll be back in a moment. Feel free to pause it. It's just like the player. We're setting the position, the trajectory based on the data set. We're going to move over to the enemy long script file. We just need to know what's changing between the variables and the functions. So position, rotation, color, function save, turn a dictionary. Feel free to pause the video and then enter the values of the save dictionary. And let me know if you prefer this versus me typing it out. I want to try to strike that balance. Now that we have the save data of the enemy, there's one more thing we need to do that's different than everyone else. In the save and load example scene, there are two containers, the top container and the left container. This enemy can both be red and come from the top and be blue and come from the left. We need to account for that when we're saving our data so we know how to bring it back and put it in the right container. All we need to do is go and add the parent name to the save data so we can just check which one it should belong to. Come in here and let's just add parent name to the save data here. Get parent.name. We need to add the load save with the data. I'm going to really quickly skip through this and you can see it in a second. The setting of the data here looks familiar. The only difference here for the color, the black color is a color object. We're setting the red, green, and blue. We just want to make sure that the two different color recs are set to this new color. Let's head back to our save and load example here. And now we're gonna finish this up. And here's a cool part. We don't need to add anything to our save method. It's done. Just by adding that group saveable to the node, it now automatically calls that save method we defined. We don't have to worry about that anymore. Now we just need to worry about loading the data. Now we know that these are dynamic and everything that gets saved is gonna need to have to be created and added to the scene tree. We can actually just find out how many nodes exist in this save data object and then just create a node for everyone that's in there. Now we don't need to create one for the player because we have already created them by this load save. We don't need that data anymore in memory. Save data dot erase the player. Now we can iterate through the data set within the dictionary pretty easily, and it'll be by the node's name, which is perfect for when we need to create the node in the scene. For node name in the save data, get all the keys. Now we can check to see if the name of the node matches which enemy we're wanting to load. In this case, let's just load that flying square. There's no extra which container does it live in logic to have to worry about. If enemy rectangle in node name var entity equals null, entity equals enemy rectangle dot instance enemy container top dot add child entity dot load save from the save data for this node's name. Let's now take care of the other type of enemy. Enemies long in node name, set up a new entity. The entity, the enemy long, instance it. Now we need to determine which container does it live in. Is it in the left or is it in the top? To do that, we need to actually get the save data, create a new variable. We first need to make sure that the parent even exists in the data set. If not, save data for the node name has parent name. Let's just skip. Create a new variable, call it enemy save data. Get the save data for the node if top in enemy save data for parent name. Enemy container top add child entity. Else enemy container left dot add child entity. Entity dot rotate degrees and color vector2 dot right. Break out of the if else and just say entity load save enemy save data. Since they will both use the save data, let's take it for a spin. I like to start on the game over screen just to start from a scratch, just in case there is any save data that we just want to clear out. We've got these enemies here, and if I get killed by this one, now I should have a chance to try again. Load last save. There we go. And nice save. Obviously, there are ways to improve the when it should be saving, but this will get you going to save your data. That's saving for JSON dictionaries. I hope you learned something new today. Hit that like button if it was helpful. It really helps me know that these tutorials work or are useful. It really helps me, and I appreciate it. Subscribe for more content, especially when part 2 drops. And as always, stay safe, stay awesome, and I don't know, maybe check out this video. It might help you.